Hello guys, this is the continuation from the previous session where I was covering ratios, proportions and rates. Later on I will discuss briefly the conversions. Thank you very much and don't forget to subscribe to our YouTube channel. See you on the next session. Hello guys, welcome again. Remember we are talking about distance, speed and time. So I'm just gonna express this so that you understand. So this one is the distance, and then speed, and then this one represents time. So let's take a look at this triangle. So this triangle represents formulas that are used when calculating speed, either speed, time or distance. Let's break it down. So let's take a look. What if the question wants you to calculate the distance? So it means that you're going to write distance will be equals to S multiplied by time. S for speed multiplied by T for time, right? But what if the question asks you to calculate the speed? It means it's going to read as follows. It's going to say speed is equals to D divided by time. So it's going to look like this. And then lastly, when the question asks you to calculate time, it's going to be distance divided by speed. Simple as that. So basically this triangle represents these formulas. If you can be able to understand these formulas, then you can be able to calculate what is required in this equation. Furthermore, let me first give you a typical example. Let's say, because on a previous session, we spoke about time. So we basically calculated time. The time it took me to depart from here and arrive in Johannesburg. Now let's talk about the distance, for example. So this is the value that you won't be given. However, they will give you speed and time, right? So let's see if we can work this out. Let's say I drive here on a speed of 100 kilometers per hour. So this is our speed, right? And then of course you'll be given time as well to determine the distance. Let's say that it took me around about 4 hours 30 minutes to arrive in Johannesburg. So our time is going to be 4 hours 30 minutes, right? Let's put it like that. So on our previous example, you will remember that this is equivalent to 4.5 hours in counting. So let's see if we can be able to calculate the distance with the given values. So what we're going to do is that we're going to implement the formula. We're going to say distance is equals to time is equals to speed multiplied by time. Then what is our speed? Our speed is 100 kilometers per hour multiplied by our time, right? Which is 4.5 hours. Okay, let's use the calculator and find our answer. 100 kilometers per hour multiplied by 4.5. This gives us 450 kilometers. Remember, the distance when it comes to road is measured in kilometers. Remember that as always. So basically, it took me, the distance that I covered is 450. If I was driving 100 kilometers per hour for 4 hours 30 minutes, right? So that is our second example. Let's quickly look at speed now. If we can be able to calculate speed. So again, we have to implement the formula. The formula for speed is S is equals to distance divided by time, right? Let's see if we can work that out. Remember, if you are required to calculate speed, it means you have been given the distance and also the time. Okay? So, we're just going to use the previous example to answer this question. So, our previous distance was 450 kilometers. And our time was 4 hours, 30 minutes, which is equivalent to 4.5 hours, right? So let's use this information to calculate the speed. Basically, we are reversing the situation to see if we did it right. So let's implement the formula now. So what is our distance? Our distance is 450 kilometers divided by 4.5. Divide by 4.5. So this is time. So basically, these two units, they are going to be on our final answer. Let's see. So it's going to be 450 divided by 4.5. So there we go. Our previous is going to be 100 kilometers per hour. Remember, this is the time that represents hour. So it's going to be 100 kilometers per hour. It is this simple. Basically, if you can be able to understand that triangle and the formulas thereof, you'll be able to calculate this kind of equation. So now, I want us to move on and talk about conversions. So you know that there are different kinds of measurement units. And before I touch on that, let me remind you that if we're talking about measurements, if you write the value without the unit after it, you'll get it wrong. Why? Because we won't be able to tell whether that is a quantity of animals or bags or whatsoever, or it's a rand. You have to always write the unit after the value. So I'm going to start with the most common equation, which is volume. In most cases, in our day-to-day life, volume is measured in liters. And also, another rule, it has to be in cubic. You have to remember this too. So, volume has the following formula. Let's say we're dealing with a rectangle. A rectangle is the shape like this, which is a 3D, right? So, in that shape, we have the length, the breadth, and the height. Length, the breadth, and the height. This is very crucial. These are very crucial dimensions when it comes to volume. You have to pay attention to this. Let us give our shape dimensions. Let's say this side is 30 centimeters, and let's say this side is 20 centimeters, and then let's say this side is round about 22 centimeters, right? So let's see if we can be able to work this out. The question will come as follows. Calculate the volume of the rectangle, and then you'll be given these dimensions. Remember, in a case like this, you are more likely to find it very confusing, because first, you have to know which side of the shape you're working with, right? The length, the volume, the length, the breadth, and the height. You have to be able to understand these dimensions. But what I can say is that in most cases you are given the formulas. When you're given the formulas, it's always advisable that you use those formulas that you're given. But you have to understand them before you use them. Don't use the formula that you don't understand. Otherwise, you will lose a lot of marks. So let's see if we can substitute this formula. So, volume is equals to, what is our length? Our length is that, along the side, 30 centimeters. What is our breadth? There, 20 centimeters. And then what is our height? 22 centimeters, right? There we go. There we go. Let's calculate and see what is our total volume. So it's going to be 30 multiplied by 20 multiplied by 22. That gives us 13,200 centimeters cubic. Very important. If you fail to write cubic, then you're going to get your answer wrong. So it's very important that you write centimeters cubic. If you fail to write the measurement unit, then you won't be able to get it right? So that is our first example. Let's go on and take a look at the area. The area. As compared to volume, the area only deals with two sides. So, the formula of this area will read as follows. Length multiplied by breadth. And it's always expressed in square. Remember that. It's always expressed in square, right? So, let's go on and have an example for this. So, let's say you have a shape, another shape like this, and then here we have 10 centimeters and here we have 20 centimeters. These are the basics. That's why they are not really sophisticated. They are very easy and they are very fundamental to understanding measurements in mathematical literacy. You have to pay attention. Let's execute this formula. What is our length? Our length is 20 centimeters multiplied by our breadth, which is 10 centimeters, right? Good. So let's see. 20 multiplied by 10 gives us 200 centimeters squared. Very important. Squared. You fail to write squared, you're going to get it wrong. Just always remember to write the measurement unit at the end of your answer, right? So that is very simple, straight to the point. Now let's get on to the more sophisticated questions. The question will display on the screen, so I'm just going to focus on answering these questions. You can copy them there on the screen. So let's take a look. I'm going to write the basics so that we all see and understand, like in the flow of how I answer this question. So we have 77 bags, which is equivalent to 1 meter cubic of concrete, right? And you are given a structure. You will see there on the screen. You are given a structure like this one. And in this structure, they have indicated to you that the volume are as follows. This side has 2.7 meters cubic and the inner has 3 meters cubic, right? This is what you're given, right? So we have the bag of cement and then we have the concrete. So basically we're trying to find out how many bags of concrete, how many bags of cement can a certain capacity of concrete be able to accommodate or be used to mix this concrete and cement. So let's see if we can work this out. The question therefore is, how many bags of cement are we going to require? Right? So you know that, remember, this is just a continuation from what we've been talking about from our previous session. So it's all about understanding the basics. So we know that 77 bags is equivalent to 1 meter cubic, right, of concrete. So this is a bank of cement and it's equivalent to 1 meters cubic of concrete, right? And there you have the area and you're given the values. So we have 2.7 meters cubic and 3 meters cubic. So let's see if we can answer that question. So let's start with the outer part. 7.7 of bags is equivalent to 1 meters cubic of concrete. Now, remember, let's take a look at this concrete here on the outer side. So the concrete there is 2.7 meters cubic. So let's see how many bags we're going to require for cement. We're going to use that approach again, cross multiplication. So 7.7 of bags multiplied by 2.7 meters cubic, right? So this one crosses with that one. So let's see what we have. So it's going to be 7.7 multiplied by 2.7. So that gives us 20.79. Right? 20.79. Remember, it carries a B here for the bag and also meters cubic. Let's put a little bit there and centimeter cubic. Right? Now, we have to divide it by 1 meters cubic. Let's divide that by 1 meters cubic. So, remember, I made a mistake, sorry, not centimeter, meters cubic. Meters cubic and meters cubic, they're going to cross each other, right? And then what we're going to left with is only the bags. So it's going to be 20.79 of bags, right? So let's see if we can round it off. So it's going to be 21 bags that will be required for only the outer side of this portion. Now let's look at the inner side, right? So we're going to implement the same procedure here as well. So 7.7 of bags is equivalent to 1 meters cubic, right? And then 3 meters cubic would be equivalent to how many bags? This is what we want to find out. Remember, cross multiplication. So it's going to be 7.7, which is will be there for bags, multiplied by 3 meters cubic, right? Let's see. So it's going to be 7.7 multiplied by 3. So that gives us 23.1. What? A little bit there, B there, and meters cubic. Divide by that 1 meters cubic right there. So 1 meters cubic right there. Remember, they're going to cross each other, and then we're going to be left with the bags. So it's going to be 23.1 of bags. Let's see if we can round it off. So it's going to be 24 bags. It's going to be 24 bags, right? So now we have to find the total number of these bags. So I'm gonna write up here. So we have 21 bags And then we have plus 24 bags, right? There we go, right? And this is one of the most simplest equation you can ever have. The total here is 45 bags. So basically, in overall, the total number of cement bags that you're going to require to fill this with the concrete, those are 45 bags, right? So, we're done with this example. I'm going to go on to the next sophisticated example and see if we can work it out. Remember, even this one is going to show on the screen. You can copy this example. So, the example is as follows. We have the flow area, which is 30 meters squared. Remember, when we talk of area, it's always equated to square, right? Remember that, as opposed to the volume, which is equated to cubic, right? So that is our flow area. Let's say that is our flow area, right? Now, what they are telling us there is that the paint is given as 1 liter, which covers 11 meters squared. So basically they want to paint that area, and then you're being told that 1 liter of paint covers 11 meters squared, right? And then they further indicated that this paint is sold in 5 liters tin, of which is sold in 5 liters tins for 449 rand per tin. This is very important. Per tin. This is very important. Per tin. And then they ask you, what is the total cost of the paint if you were to paint this floor area, the whole of it? What is the total cost? So let's see if we can come up with a solution for this one. So remember, you have been given the ratio that 1 liter is equivalent to 11 meters squared. Let's write it down. It's equals to 11 meters squared, right? Good. And then the amount of area that you are required to cover is 30 meters squared, right? So basically what you're trying to find out is the liters of paint that you're going to require, right? So I'm going to put a question mark here. This is what we're trying to find, right? We're going to go on with the same approach. So it's going to be 1 liter multiplied by 30 meters squared, right? And then later on, of course, we're going to divide that by 30 meters squared. I mean by 11 meters squared. So it's going to be 30 meters squared, of which it also carries a liter here. So remember that it also carries a liter because these two, we are working with these two measurement units, so they carry the whole value with us. So we're going to divide this one with 11 meters squared. So 11 meters squared plus, they're going to cross with 30 meters squared. The measurement units, they're going to cross with each other, and then we're going to be left with the liters that we want. So this is the liters that we want, the question mark that we put here. So let's see. So 30 divided by 11. So that gives us 2,72. 2,72. Right? I'm going to round it off because it's 2,727. I'm going to round it off to 2,73 and leave it there. Remember, monetary values are always rounded to 2 decimal places, and do not round unless stated otherwise. So let's see if we can work this out. So what is this? This is the capacity, the paint that you're going to require to cover that area, right? So is this our final question? No, this is not our final question. Now we just found the liters that we're going to require to cover that area. The question wanted what? The cost. Let's see if we can work that out. They have indicated to you that these paints are sold in 5 liters tins for 449 rand per tin, right? So let's see how much it's gonna cost. They have indicated to us that they are sold in 5 liters tins for 449, right? For 449. So let's see. So basically the paint that we need is 2,73 liters, which, if we can take a look at this, is less than the capacity of what's inside the tin, right? Because it's only 2,73. Yes, so you can see that this is less than the capacity of what is required in the tin, of which they only sell this in a tin of 5 liters for 449. So what that means, it means that you're going to buy only one tin. You're going to buy only one tin, which is 449.00. Yes, and then out of that you are going to be left with certain amount of paint. Thank you very much. Watch out for other videos.